Hello everyone and welcome back to System Design Mastery. My name is Pradeep Kumar Wala and today we are diving into one of the most important decisions every software engineer has to make. Which database should I use? This is topic 5, part A, and here is the thing. This decision sounds simple. SQL or no SQL. Pick one and done. But engineer at companies like Instagram, Netflix, Uber have made this decision wrong and it cost them week of painful migration work. By the end of this video, you will understand exactly what SQL and NoSQL are, how they differ, and which one belong in which situation. Let us get into it. Here is what we will cover in this video. First, what is database? We build intuition before we touch SQL or NoSQL. Second, SQL databases, table, schemas, ACID properties with real bank story. Third, NoSQL databases, four completely different types, each built for a different problem. Fourth, full head-to-head comparison, SQL versus NoSQL across 8 dimensions. And finally, a quick decision guide, 3 questions to start pointing you in the right direction. The full decision framework with real company example, indexes, sharding and replication is all in topic 5 part B. This video gives you the foundation. Before we talk SQL versus NoSQL, let us make sure we understand what database actually is. Think about a library. A library stores books, it organizes them on shelves, it has a card catalog so you can find what you need fast. And there are rules. You cannot just put a book anywhere. Database is exactly the same idea, but for your application data. The library is your database. A book is a record, one row of data. A shelf is a table, a collection of related record. The card catalog is your index. It makes lookup fast. The librarian is your database engine, the software that manages everything. And library rules, that is your schema, the structure every record must follow. Why database matter? Now, why does every application need database? Because without one, your data lives only in memory. The moment your app restarts, everything is gone. A database persists your data, it survives crashes, it handles thousands of users reading and writing at the same time. It makes retrieval fast even across millions of records. Every app you use right now, Instagram, Netflix, WhatsApp, is powered by databases running 24 hours a day, 7 days a week. That is not magic, that is engineering. SQL stands for Structured Query Language and the keyword there is structured. In SQL database, data lives in table. Each table has column defined in advance. Every row in the table must follow the same structure. Look at this user table on the screen. Every user has an ID, name, email and plan. Not some user, every user without exception. That is consistency is what makes SQL powerful. You always know exactly what shape your data will be in. You have probably heard of MySQL, PostgreSQL, SQLite, Oracle. These all are SQL databases. They all follow the same relational model. ACID properties. Now the most important concept in SQL databases, ACID. ACID is not just a word, it is a guarantee. A for atomicity. Every transaction is all or nothing. C for consistency. Data always moves between valid state. I for isolation. Concurrent transactions do not interfere with each other. D for durability. Once committed, data survives even a power failure. Let me make this real with a story. You transfer 1000 rupee from your bank account to a friend. The bank has to do two things: debit your account and credit your friend account. What if the debit succeed but the credit fail? Without acid, your money is gone. Your friend never received it. With acid, atomicity kicks in. The entire transaction roll back. Your money stays in your account. Nothing is lost. That is why bank, stock market, payment system all use SQL database. When correctness is non-negotiable, acid is what you need. Now NoSQL. And I want to stop you right there if you think NoSQL is just a one thing. It is not. NoSQL is a family of four completely different database types. Each one was invented to solve specific problem that SQL struggles with. Let us go through all four. Type 1, document databases. Think of it like folder of notes. Each note can have a different field. One note might have title, body and text. Another might have photo and location. No fixed structure required. MongoDB, Firestore and CouchDB are a document database. Instagram uses document storage for post because every post has different mix of photos, videos, captions, location and text. A rigid SQL schema would be painful here. Type 2, key value databases. The simplest possible model. You have key, you get a value. Blazing fast. Think about dictionary. You know the word and you instantly get the definition. No searching, no scanning, just direct lookup. Redis, DynamoDB, Memcached are the key value store. Every time you log in into an app, your session is probably stored in Redis. Key equals your session token, value equal your user data. Millions of lookups per second, millisecond response time. Type 3, wide column databases. Imagine a spreadsheet where each row can have completely different column. Row 1 might have 10 column, row 2 might have 50, and write are extremely fast even at billions of row. Cassandra, HBase, and Google Big Table are the wide column databases. Netflix store your watch history in Cassandra. Every time you watch something, that is right. Billions of writes per day. Cassandra handle it without breaking a sweat. Type 4, graph databases. This one is fundamentally different. Instead of rows and columns, you store nodes and relationships. Think about social network. You are connected to your friends are connected to their friends. Graph database make this connection first class citizen of the data model. Neo4j and Amazon Neptune are the graph databases. LinkedIn uses graph databases to answer the question, how are you connected to this person you do not know? Second degree connection, third degree connection, graph traversal make this instant. So, to summarize, four types for completely different problems solved. Document for flexible data, key value for speed, wide column for massive write, and graph for relationship. Now let us put them side by side across 8 dimension. First one is structure. SQL uses fixed schema. You define columns upfront, every row obey that structure. NoSQL is flexible. Each document or record can have a different field. Relationship. SQL has joins built in. You can combine data from multiple tables in single query. NoSQL generally doesn't have join. You embed related data or handle it in your application. Scaling. SQL scales vertically. You add more CPU and more RAM to the same machine. NoSQL scale horizontally. You add more machines to the cluster. This is why NoSQL handle massive scale better. You keep adding machines infinitely. Speed. SQL is optimized for complex queries, aggregations, joins, filtering across related tables. NoSQL is optimized for fast read writes on simple data, usually microseconds. ACID. SQL gives you full ACID guarantee. NoSQL traditionally uses eventual consistency. Data might be slightly stale for a brief period. Many modern SQL databases now offer ACID for some operation. Examples: MySQL, PostgreSQL, and Oracle for SQL, MongoDB, Redis, and Cassandra for NoSQL. The key insight is here. SQL and NoSQL are not competing, they are complements. Most large scale systems use both. Okay, you understand the SQL, you understand the four types of NoSQL. How do you choose one? Here are the three quick questions to start the decision. Question number 1: do you need complex join? If yes, go for SQL, PostgreSQL or MySQL. If no, NoSQL is a strong candidate. Question number 2: do you need extreme write speed at massive scale? If yes, NoSQL, Cassandra or Redis depending on the use case. If no, SQL handle this fine. Question number 3: is your schema changing rapidly? If yes, go for the NoSQL. MongoDB gives you the flexibility to evolve without migration. If no, SQL. A stable schema is actually a strength with SQL. Now, these three questions are a starting point. The full picture is in topic 5 part B. In topic 5 part B, we go deeper, real company choices, what Instagram chose and why, how Netflix picks its database per use case, how Uber handle its scale. We also cover indexes, sharding and replication, the three operations that make database scale in the production, and the complete 5 decision framework plus top interview questions and answer. Topic 5 part B is the practical application of everything you learned here. Watch it immediately after this one. Let us close with what you know now. 1. Database persist, organize, retrieve data. Every production application need one. 2. SQL databases uses fixed schema, table and ACID transaction. Best for structured relational data where the correctness is critical. 3. NoSQL is not one thing. It is a four type: document, key value, wide column, and graph, each built for completely different problem. 4. SQL scale vertically. NoSQL scale horizontally. Neither is universally better. Context decides. 5. ACID is SQL's cost guarantee. Atomicity, consistency, isolation, and durability. It is what makes bank transfer, payments, and financial systems safe. 6. Topic 5 Part B takes everything here into the real world, real company choices, sharding, indexes, and the full decision framework. If this video helped you, please hit the subscribe button. Every subscriber genuinely helps this channel reach more developers. Drop your questions in the comment. I read every single one. Topic 5 Part B is the next. See you there.